A select group of students retraced the thinking of an ancient scholar to calculate the circumference of the Earth.
It's cute.
Chief scholar at the Library of Alexandria, Eratosthenes devised an elegant method of measuring the globe through the observation of shadows. We adapted this method to recreate this calculation today. Poles are placed in both New York and Florida to cast shadows with the intent of finding the pictured angles alpha and beta. These will then be used to calculate central angle phi as follows. By determining arc length S between the locations in New York and Florida, taken together with phi, proportional reasoning will produce the circumference. So the circumference is the arc length times 360 divided by phi. Whoa. Observations are being made at St. Joseph's College on Long Island, New York, as well as in Englewood, Florida. The longitude of these two locations is different, therefore the timing of the observations will have to be adjusted to account for the rotation of the Earth. Also, a straight line cannot be drawn along a line of longitude between the two. We would need a boat for that. To compensate for this geographical limitation, the city of Ashland, Ohio was selected as a point of reference due to the fact that Ashland is at the same latitude as St. Joseph's and the same longitude as Englewood. One could theoretically drive closely along a north-south line of longitude from Ashland to Englewood and note the mileage. We use Google Maps for this. This distance will give us our needed arc length S. Observing the path the sun takes across the sky, it is at different heights relative to the horizon at different times. Being that Long Island is more easternly located than the west coast of Florida, at a set time, the sun will appear to be at a different height. If one were to make observations at the same clock time in these locations, an error would result, as pictured. To compensate for this, observations are made at local noon for each site, 37 minutes apart. We calculate phi to be a remarkably accurate 13.4 degrees. Using that, together with arc length S, we come up with a circumference of 30,734.33 miles. These results are great for just looking at some shadows. However, there still is a 23.6% error from the accepted value. We feel the greatest source of error is in the arc length S, which was come to by measuring the nearest roadway. If, however, we hired someone like Eratosthenes did to measure the actual arc length, somewhere close to 952 miles, our error would be reduced dramatically to 2.9%. Remarkable.